Welcome to my session. So in this session, we're going to talk about how to use Open Policy Agent, OPA for short, Gatekeeper, and then can be used to strengthen your supply chain security. Like Safa introduced me, my name is Sertaç Özercan. I'm a principal software engineer lead in the Azure Core Upstream team at Microsoft and a maintainer in the OPA Gatekeeper project. So in this presentation, we're going to start with what is Gatekeeper, who is Gatekeeper for, and then we're going to talk about Gatekeeper's core features. We're going to look at brief architecture, and at the end, we're going to see some exciting demos. Okay. Thank you. First, what is Gatekeeper? Gatekeeper is a customizable Kubernetes admission and mutation webhook that helps enforce policies and strengthens governance. Gatekeeper enforces policies through Open Policy Engine. And OPA is a policy engine for cloud-native environments in a CNCF graduated project. And then in this presentation, let's see how you can leverage it to extend supply chain security and governance in your Kubernetes cluster. If your organization has been operating Kubernetes, you've probably been looking for ways to control what end users can do on the cluster and ways to help ensure the clusters are in conformance with company policies. And these policies may be there to meet governance or legal requirements or to enforce best practices and organizational conventions. And then after talking to customers, we heard that admins would like to automate audit and enforcement of policies to free up their time while defining common best practices across the organization. On the other hand, developers would like to be able to self-service deployments of their applications and fail fast with actionable feedback and items if something is not compliant. And as you can see, policy is a team effort, and Gatekeeper was built with this philosophy in mind. Separating these roles into discrete areas allows for specialization where work in each area benefits the other and increases its scale. So let's talk about a few personas. First of all, the policy authors. The policy authors would like to figure out how to implement common generic checks. For example, they would like to be able to restrict labels on Kubernetes resources, but they don't care about which resources or which labels or how this gets enforced. And then for cluster admins, they want to figure out what checks they want to use. For example, they may want to restrict the owner label for objects in the prod namespace. So they can figure out who the owner of an object in the prod namespace is. And then last but not least, developers would like to figure out how to deploy their applications. And in this case, they want to deploy their service in staging in production, and they want to fail fast if something is not compliant and have a quick turnaround with actionable feedback and in messages. Okay. So let's talk about Gatekeeper's core features. So Gatekeeper comes with a validating admission control to validate Kubernetes resources. So this controls what end users can do on the cluster. And in a mutating admission control that is currently in beta right now to alter resources as they are being created. For comparing resources like uniqueness, you can use referential policies using OPA cache. And policies are defined via a query language called Rego and can be parameterized and configured. And we also provide a community-developed policy library that contains general policies as well as alternatives to pod security policies, including mutation. In external data, which we're going to talk a lot more about in this presentation, enables Gatekeeper to interface with external data sources. Right now, it is in the alpha stage for validation, and it is in development for mutation. And then it kind of ties in with the OPA's custom built-in functions that's written in Go. We're going to also talk about that, how you can take a Rego that's query language for OPA, and then have a bridge to execute Go in there. And then, so this basically allows for extending the Rego language using Go. Cool. And then continuing with the core features, audit. Audit will periodically check the cluster for non-compliant resources and provide a report. Dry run. And then dry run will deploy policies without enforcement. So you can gain confidence before rolling out a policy, so you don't block users without actually trying out first. Namespace exclusion. And you can use namespace exclusion for excluding certain namespaces, like kube system, for example, from validation or audit or mutation, any of these operations. And then we also provide metrics for policies, for violations, for both validating webhook and then mutating webhook, and audit and resource sync if you're using the OPA cache. And finally, multi-pod deployment of the validating and webhook pods for high availability support. Cool. So let's talk more about the external data. All right. And in this case, it is similar to OPA's built-in HTTP send functionality, as in it can basically use for sending HTTP queries to anywhere, basically, right? However, we thought there were limitations to this approach. First of all, Gatekeeper's mutation functionality does not support Rego, and then obviously then it cannot use OPA's HTTP send built-in functionality, as we want to also extend external data to mutation. We also thought there were security concerns due to a multiple number of factors. So first of all, if the template authors are not trusted, it will potentially give them access to the in-cluster network. Say, for example, let's talk about like the log4j vulnerability. If the template author is not trusted, they could potentially send a request to an in-cluster pod exploiting that pod's weaknesses, even though that pod may not be exposed anywhere else. And then if template authors are trusted, authors will need to be careful on how Rego is written to avoid injection attacks. Cool. And then let's talk about the external data benefits. So first of all, it addresses the security concerns by restricting which hosts a user can access. And then we're going to see how we can deploy provider objects on limiting this behavior. And it also provides an interface for making requests, and then which allows Gatekeeper to better handle things like escaping strings. Another big advantage is it provides a provider-based model for common interface for extending Gatekeeper with external data. So all the providers can use sort of the same guidelines and standards instead of each of them kind of doing their own thing. And then this will also benefit on performance optimizations, because we can now directly control caching, and then which values are significant for caching, and then that will increase the likelihood of cache hits, which will increase the performance and decrease any potential timeouts. Okay, so let's talk about some use cases. So in this presentation, we're going to look into more on the validation use cases. So first of all, it's image signing. So checking whether an image is signed, for example, with a cosigned signatures or Notary V2 signatures. Checking if an image has an attestation, for example, an in total attestation is attached to it to the image, for example. Checking image vulnerabilities. This can be done with a scanners like Trivi, Gripe, or any other ones. So when you deploy a potentially vulnerable container, you get alerted right away that, hey, here is like there's like 5 critical vulnerabilities, for example, which we're going to see in the demo later on. Software bill of materials, SBOM validation, which is, and then you can think about, if you're not familiar with SBOMs, you can think about that as like a sort of food ingredients, basically, right? Like nutrition facts of a software. And then checking whether an image has an SBOM in the first place, or whether that SBOM contains certain licenses, or maybe not contain certain licenses also, maybe your organization does not approve, or certain dependencies also, like a specific version of it. So again, coming from like the log4j, you could check for like a, hey, that is that specific version of this library is in my code, or has been used for building my code. And then talking about some of the mutation examples, a tag to digest, for mutating an image tag to a digest. So for pinning a tag, an image tag to a specific SHA. So it even though if the tag can be mutated later on, that the digest won't be mutated, so you'll know what you're pulling and what you're getting in your cluster. In another example of a mutation that I didn't cover, that's not particularly important in for the supply chain security, maybe, is Active Directory integration. For example, adding labels or annotations for adding owners, such as your organizational team, like deploying a pod or like a config map or something like that, and automatically getting that resource mutated with owner as with your team. So if somebody's looking at it, they'll automatically know, hey, this team created this resource. Okay, so let's break down the ingredients and look at the architecture of Gatekeeper. Oh, I just changed the slide, but looks like Google slide did not get updated. So I will go through this one a little bit. Okay, cool. So this one is basically showing the external data feature. So first of all, Gatekeeper supports both audit time and admission time checks. And then this diagram is a high level of how Gatekeeper serves admission requests. And then if you don't look at the external data and data provider and the external data source on the right side, and then just on those other 3 blocks, those would be like the static validation. And then when something makes a request to the API server, for example, making like a kubectl request, the API server receives that request and then sends an admission request to Gatekeeper's validating repo. So it's asking Gatekeeper, hey, should I allow this request to proceed, right? And then Gatekeeper must answer this yes or no, and then the API server can take an action, right? And then, but to do this, to say yes or no from Gatekeeper, Gatekeeper consults its policy configuration, and then this is this larger box. Whoops. Larger box at the bottom of the slide. In the green object labeled constraint, it tells the admin what checks they want to perform. And in this case, for example, require image signatures or require image SBOMs. And then constraints rely on templates. And in the template is the blue object to tell the system exactly how to perform the check. So that's basically where the code gets written, right? So in this case, check if that deployment or this pod specs image is signed, right? However, like I said, this is specifically for external data. For regular resources, say you're deploying a config map, this admission request is already provided this request is already provided in the admission request. So you can see, hey, I want to check if this config map has this label, right? But in our case, in this example, it is a completely external thing that, hey, this image signed, which and then the source of truth is in an external data store, such as a container registry, right? And then so the way that my notes, yeah. So since image signatures are stored externally, we need to check the data sources to validate whether they're signed or not through the gatekeeper external data. And then the data returned back to the gatekeeper through external data should contain information for gatekeeper to say yes or no regarding the admission request coming from the Kubernetes API server. Okay, so this is where we define the URL of the provider. So in this case, we are going to use in this example, we're going to use the cosign provider. And in this case, it's an in-cluster service, and then there's like an in-cluster deployment. So the URL is the link to the in-cluster service, which then points to the in-cluster pods. And then here we have a constraint template example that sends an external data request to a provider. So in the green box, we have the Rego rules executed against an admission request and returns a violation from the response of the external data provider. Images, and then you can see over so after it says build a list of keys containing images. There are a list of batched images from pods container images. So we can send a single request to improve performance and reliability. And then the way that the provider basically works is it basically references to the provider object we just defined called cosign gatekeeper provider, right? And then it basically sends the images as part of keys, right? And then this is the part that I was mentioning earlier that we are extending OPA's query language called Rego, which is in this case this one, with Go code. So in this case, external data is a custom function that we added. In this case, when a user does an external data call, it translates this into an internal API request that is built with Go. And then this will be sent through the to the external data provider. And then when the external data provider sends back the data response, it will go into this response object. And then depending on how that Rego is constructed, it could say invalid response or whatever the code wants it to do, right? And then next piece is the constraint that we want to apply for our constraint templates. So here we have the constraint of the kind Kate's external data cosign as defined from the constraint template in the previous slide. And then here an admin can define the scope of enforcement and only apply this. So this one says basically only apply this rule against the Kubernetes deployment kind in the apps API group and in the default namespace. We don't have parameters in this example, but a cluster admin can also pass in parameters in a constraint to the constraint template. So you can also use parameters as certain values. So it could be regex, for example. So for example, if you wanted to say, hey, I only want to allow images from my private registry, so which is like a kind of a static validation, but you can have like a regex there that can say, and then that private registry can change like anything within your company's domain, for example. Okay. So let's look at a demo. So I'm going to share a video. Hopefully this will work. So would you be able to get the video?
Are you uploading the video right now, or?
I just shared the video in this StreamYard.
Okay, I'm just looking right now, but I actually don't see any video right now. Let's have a look. So there is a share and the video file. Did you click on it?
Yeah, I did a share and then the video file, and then I clicked on the video. I can see it on my side, but I'm not sure if it's.
Okay, wait. Yeah, I think I saw it. Wait a second. So I'm just adding to stream right now.
Cool. Yeah. Okay. So yeah. Thank you, Sam. So in this case, we're going to start by creating a Kubernetes cluster using kind. So there's no like a magic involved behind the curtain. So this is like a generic kind Kubernetes cluster using Kubernetes 1.23 called demo. So it's going to take a second to start. Almost there. Okay, cool. So, and then let's do a get pods with all namespaces and basically nothing else running in our kind cluster. It's pretty much vanilla. And then now we are going to install Gatekeeper through the Helm chart. This is the version 3.7.0 of Gatekeeper with external data enabled. And we're going to deploy into the Gatekeeper namespace. Excuse me. Okay, so and then it's going to start the Helm deployment. It should take a second to deploy. Cool. So now we have our Gatekeeper installation in the cluster. And as you can see, we have the Gatekeeper controller manager pods, which control the mutation and validation piece, and then the Gatekeeper audit deployment, which does the periodical audit checks, as we mentioned earlier, and then it will audit all Kubernetes resources periodically. And then we are going to go ahead and deploy the cosign Gatekeeper provider. And then this provider comes with its own namespace, deployment, and a service. And then we are also deploying the provider. And I'm just going to print out the provider as we just saw earlier. And then here is the constraint template we just looked at that we're doing the external data request and then getting result back. And depending on, hey, this is signed or not signed, we are going to say invalid response and then why it's invalid, for example. And then here is our constraint. So again, like I mentioned, we are applying to deployment in the apps group and then the default namespace. And then what's also another interesting thing is the enforcement action. The deny is a default behavior. So if a resource is in violation, it will block that deployment with an error, right? So that's one of the things that we want. The other thing that we talked about was dry run. So then dry run will let the resource go through, even if it's violating. But as part of the audit, it will be caught. So it will be in the audit results. So even if it's in violation, it will be part of the audit results. And then the last enforcement action is warn. So it is similar to dry run, but it will provide a warning similar to the deny message. But instead of being a deny, it is a warning. So it will still the request will still go through. It will be admitted, and it will be in part of the audit too. But you'll get a warning as part of the kubectl command. So, and then the first example, we're gonna look at the deployment that we think that is going to error out. So in this case, we're gonna deploy I don't know if you can see it, maybe. I will just read it, gone through. Okay, cool. So yeah, we're gonna deploy an Nginx pod, which is obviously not signed in this case. So in this case, the error, I cannot see it because I am, okay. Yeah, it'll say verify my signatures, no matching signatures. So, and I think behind the scenes is basically going to the cosign's full CO ledger and then checking, hey, does Nginx have a signature? And the response is getting it's, no, I don't see this one. So the gatekeeper goes ahead and then, oh, okay, I don't want this. So I'm just going to block this. So cool. So let's look at a good example. So in this case, we're going to look into the gcr.io distroless static container, which is it is signed with cosign. So and then we applied it, so it went through. So again, like mentioned, it's going to go to the check the image signature. Hey, I found the signature, so I'm just gonna. And then the gatekeeper responded yes to the API server. So and then the request went through. So in our second example, we're going to look at a image scanning example. So in this case, we're going to look into Trivy. So I'm just going to deploy the Trivy server using Helm. Okay, and then that went too fast. Cool. And then let's look at an example Trivy provider. So I'm going to deploy a manifest again. It's very, very similar to the previous example. And we have the Trivy provider and the Trivy provider object. And then the template. And this is a little different, basically. But in a similar in the logic, if the response is saying, hey, if the result is more than 0, in this case, it just returns a number of vulnerabilities. So if it's more than 0, hey, I'm going to say image, like something contains this much vulnerabilities. So again, similarly, we're going to deploy our template and constraint. These are all the same. And after we deploy our constraint, we are going to look into a vulnerable example. So in this case, we are going to look at an Alpine container. This one has some vulnerabilities. So this is Alpine 314. And then we're going to deploy this in a second, I think. Hopefully I get that one. Cool. Yep. So we are going to get that one. And as you can see, maybe I'll just go through this one so you can see it. Yeah, as you can see in the middle here, that we got 2 error messages in this time, right? Because in Gatekeeper, the constraint templates are ended together. So if an image has no signatures and has vulnerabilities, it will get both of the error messages. So in this case, it'll say, hey, there's no matching signatures, and this image contains 27 vulnerabilities, right? And then because it violates both of their both of the policies, we got both of the messages. So if any of them got violation, it will be in here. But if any of the constraints, for example, was dry run or warn, we would get like a block and a warning message, right? Or if it was dry run, it would just be admitted. So depending on how you would configure the constraints. Cool. And then in the last example, we are going to look at the not vulnerable. Again, we are going to look into the distro static, because this is like a known container for both that not vulnerable and signed. So because it provides both checks, which is convenient, it goes through. So that is the end of our demo. Sahab, do you mind going back to the slides? Thank you. Yeah, and then I provided the examples here that we just talked about. So cosign validation for signatures. Thanks to developer guy for building that example. In the ratify validation example for validating Notary v2 and cosign signatures and SBOMs. And any feedback is welcome. Please come join us. Give us feedback, open issues on GitHub. Come talk to us in our Slack channels, and then join us in the community calls. It's at Wednesdays, 9 a.m. Pacific Standard Time, which might work better for Turkey. And then also 2 p.m. Pacific Standard Time. So we skip 1 week. So one week is 9 a.m. Pacific Standard Time, and then the next week is 2 p.m. Pacific Standard Time. Please come join us.